Yeah, so when I was an undergrad, I had a philosophy prof. I don't remember what his name was, but he was, um, I don't know, did some kind of like Shotokan karate or something like that, and he was like a black belt at whatever place he was. So he kept mentioning it in class that he practices martial art or something, and at some point mentioned where he practiced. So we went to the website and he's listed on there as the White Dragon, and they had like videos of him doing like crazy flip stuff, breaking boards and stuff like that.
Wow.
So we just started calling him White Dragon in class.
Was he okay with it?
Yeah.
He's just like,
Yeah, that's my ninja name. Yeah, that's just my ninja name. I think everybody should have a ninja name. At what point, at what level of martial art do you have to attain when you've earned a ninja name?
top five.
Like, well, top five, like in what, your studio or your dojo, or is it a belt color? Because I know, I mean, I know I'm throwing everything under the umbrella of ninja, which I know that's not like right, but let's just assume it is because it's a Ninja Turtle thing. But if you're in any kind of martial arts, eventually you attain the rank of ninja.
I think my ninja name would be Mikhail the Brick Crusher.
Mikhail the Brick Crusher.
That
sounds almost important.
That seems like really specific. Is that-
I do one thing, but I do it well.
I was watching a buddy, this must have been maybe 15, 18 years ago, something like that, do his test for his black belt. I don't remember which martial art he was in, but he had to break, he was doing board breaking stuff, and I guess they held like 5 boards, and he broke his hand.
Ooh.
Oh, it was so funny. He turned like super pale, and that was like one of the first things he did because he still had to do the rest of the stuff. He kept going. Yeah, seriously. It was so good. Huh?
Did you switch hands?
Oh, no, he didn't break any more boards after that. Well, he didn't break that board. But he had to go and do like kata stuff. Like, skill showing technique and things like that to test for the belt. But he just kept going. I think so, yeah. I think he doesn't find out till later on. I kind of recall that he did, like, there wasn't like a ceremony where they came and gave him the belt that night or anything.
Apparently you can find out your ninja name at ninjaname.net. Yeah.
Of course there's a website for finding out your ninja name. Look, if it's a virus, that's a virus worth having. If you catch a computer virus from ninjaname.com, was it ninjaname.com?
.net.
.net, ninjaname.net. All .net sites are legit.
Oh yeah.
All right, let's write some stuff. All right, so shut up. You lost. You can't, when you're doing a staring contest, you can't break eye contact or otherwise you lose. It's the rule. You learn that like 2nd degree ninja black belt. Ninja belt, not black belt. Yeah, terrible V. Okay, so we are, last time we worked with an environment, and then we talked towards the end about starting to create our own, effectively our own scheme-esque language where we're writing our own interpreter and breaking the pieces apart and things like that. And this has kind of been a goal of practicing breaking things down. Now, remind me again, what's a lambda expression? It's an unnamed function, okay? And generally speaking, functions have a couple of parts, right? We really don't care about the name of a function until we need to go call the function, right? That's the only time we actually care about the name of a function. And we've seen recently the idea of like using the map function to just pass an unnamed lambda around and applying that to everything. We didn't even care about the name of the function. So functions are really about what they do, and then naming one and putting it into a variable environment has more to do with being convenient. So eventually we're going to start storing things like lambdas in our variable environments, but right now we only know how to hold numbers. That's okay. But what we want to start doing is we want to start thinking, since we're in the world of environments right now. Something you should have read about in the book is this idea of occurs free and occurs bound. We saw that stuff in the book. So let me bring up a slide here. And then I'm going to ask you what those things mean. And everybody should get it right, because I think they basically talk about it on maybe like 7, 8, 9 pages, something like that. All right, so what is occurs free? What are we even talking about? What world are we talking about when we're talking about whether something occurs free versus occurs bound? Can you all commit the book to memory? The book's a really easy read, you know. Okay, so you didn't read.
I mean, I read some.
So no. They actually had implementations of occurs free and occurs bound. We're going to implement it again. But before we can implement it again, I need somebody to tell me what it's for. Oh, come on, people. I feel like I should just give this as a quiz so everybody can just earn their 0 and then move on with life. How many of you at least recall seeing the phrase occurs free and occurs bound in the book? Okay, so there was like at least 2 implementations of it, like actual scheme code for a function called occurs free and occurs bound. All right. So when we have here, let me what?
Is it when
The Ann Arbor people are like, what just happened? Go ahead.
Is it when the local variable is used within the scope of the declaration?
Well, I think so, maybe. It feels like you maybe made up half those words.
No.
But some of the words actually are fairly meaningful.
I know what all those mean, but I'm not sure if that's what if that's accurate.
All right, so here, I'm just going to grab some random code here. Is this an example of something that's like a Lambda expression in Java? Yeah. This is a function. We just happen to have a name for it. Actually, that's a constructor, right? Here, I'll go down to a function. Yeah, here's a, actually, that was not going to be a good one. We'll go to, yeah, here's an add. So this guy is like a Lambda expression. This is in Java, so this, we happen to have named this function, but this could just as easily have been a Lambda. And since we are in Java, which is a strongly typed language, this guy has a return type. We don't deal with that in Scheme, but just roll with me on this one. Okay, so this guy's a Lambda that takes a single input, a single parameter. So now, where am I using? Okay, so right here, I'm using f. We would say that f occurs bound in this context. That is saying, a variable named f was bound right there. Okay, that's where it's bound. Variables get bound when they become part of the local scope. All right, and right now, the only way we can bind a variable in our micro language is as part of that single parameter that can get passed into the Lambda expression. Remember last time we decided we're going to make simple lambdas that limit us to exactly one input, no more, no less. You need one input. So whatever that input is, that means that that variable is a bound variable in the body of that lambda, within that scope of the lambda. So that means that when I actually use a variable named f right here, we could say that f occurs bound, because in its current scope, in the body of this, there is a binding for a variable named f. That makes sense? All right, so we would say that f occurs bound. Now, if I just randomly had a variable called LOL plus 2 or something like that, all right, we're saying that this is a symbol. We would run across that and say, that's a symbol. And then we would say, does this symbol occur free or occur bound? Well, we can just glance around and say, well, at the very least, I mean, because keep in mind, you could have lambdas inside of lambdas potentially. But in this case, we don't. We don't write functions inside of other functions in Java. But we would look up here to our single binding and say we have a single binding for f. Then we would look at this variable name and say, okay, somebody is using a variable named LOL. It is not bound anywhere. So LOL does occur. It's right there. It's real. And it occurs free. it's not bound anywhere. And that might be a problem, right? Because if we have a variable, variables resolve to the most local definition. And if we have a variable that occurs free, that means it's not bound. We don't have a value for it, right? A value wasn't necessarily passed in. Now, that doesn't mean we can't resolve it. Just because it wasn't bound in its current context doesn't mean that it's not available to us in our larger environment, variable environment that may or may not have been passed through. So when we're talking about whether something occurs free or occurs bound, for lack of a better phrase, we're really talking about, was this thing defined in my most local scope? Can I trivially find it locally? Or do I need to search in the outskirts of my program in an area that I have access? So we're kind of talking about scoping rules for variables. So when I look for LOL here, so if I say, int b is equal to LOL plus 2, for instance. When I bump across LOL and I see, okay, well, I don't see a definition for it here. So at the very least, it is not bound inside this lambda. I would then have to bump back up to my next level where it could live. We haven't written that kind of thing yet in our language, but if we're thinking about a fully functional language like Java, that's the next place to look. I look around me here in the local scope. If I don't find it, I need to look someplace else. So it might be handy for us to be able to look at a symbol and say, is this bound locally? Make sense? All right, so that's the occurs free versus occurs bound stuff. So it has to do with processing. Yep.
Can a variable be occurs free or occurs bound at the same time?
Ah, excellent question. Excellent question. So let's create a couple of examples here. So first of all, for an occurs free example, we might have a lambda that takes in an x and boils down to y. I have a single variable here that's bound, x, and I do not use it, but I have a symbol here, y. Y occurs free in that thing. Make sense? All right. Similarly, I could have a lambda that takes in an x, and the body is a lambda that takes in a y, and I have a xz, something like that. So here's my top level lambda where I have a variable bound called x. Its body is another lambda where I have a variable bound called y. Its body is what we talked about last time as an app expression, where we are applying whatever x is to whatever z is. So in this case, x occurs bound by this binding, and z occurs free. It's not bound in the local-ish scope, let's say. Make sense? All right, so that would be examples of occurs free. Z occurs free. It's not bound here or here. But X occurs bound because it is bound here. All right, so V asked the question, can we give an example where something, here, let's just say verse occurs bound. So we would say Y occurs free. We would say X occurs bound and Z occurs free. Now, V wanted an example where a single variable can occur free and bound. I don't know, what do you think?
I would guess no.
From the way that you're talking, it sounds possible.
Go ahead.
So if like we use list as a variable, so xz itself, that would occur free, correct? Because that doesn't exist as.
What do you mean? So I just say XZ like that?
Yeah, so that in that example right above, that would occur free, correct?
Which does?
If it was a
The
list of
actual
symbols.
list.
No, because the only things that can occur free or bound are individual symbols, variable names.
Oh, okay.
Yeah. Yeah, really what we're talking about is a variable occurs, is either defined or not defined
Okay.
in a scope. Go ahead.
Would an example free and bound being maybe like a for loop.
Let's stick with lambdas. We don't know about for loops in our micro language right now.
But
So here, I'll start us off. We're going to have a lambda. Then we'll pick our favorite thing here. We want to have an example where x occurs free and x occurs bound.
You just make it like using the example above, it's just z is free there.
Mm-hmm.
Then you're passing. Okay, I think I get the logic, but I don't know how to write it. You have one function inside another, one's free, one's not.
Okay, yeah, so we can create an app expression. We can have an app expression where we have a lambda x y. In that case, y occurs free. And then the second thing could be a lambda y. In that case, y occurs bound. So we have a single expression, an app expression, where y occurs free and y also occurs bound in a single expression. Fair enough? Puzzle type stuff. Okay, but what we want to think about is whether variables can be resolved locally or not. That's the kind of the punchline of occurs free versus occurs bound. All right, make sense? Go ahead.
Technically, aren't those two different instances of y?
Well, yes, but the variable y occurs free here, and the variable y occurs bound here, and this is a single expression. That's an app expression that happens to have two separate things. They are two separate instances, you're right. Okay, so if we were going to come in here and we wanted to write the occurs free and occurs bound functions. So we want to ask a question given an expression, any kind of expression, all right? Now, can we apply, I mean, I just gave you an example here where we are applying occurs free or occurs bound to an expression of type app expression that we talked about last time. Now, I'm telling you that in our micro language right now, the only way variables can be bound is by the lambda expression. The only place we can bind stuff is right here. That's where bindings take place. Make sense? So whenever we bump into something like that, we know that we have a binding. All right? So we want to write a function called occurs. We're going to actually do it in here as a starting point. So if I gave you something, we'll do a simple one first. So if I have an expression, lambda x, y, and I want to go through and I want to ask, does the symbol y occur bound in this? What would we do? I would have to start processing in. When I say occurs bound, we're asking the question, does y occur bound in the expression below? I think the thing we're building is what, an LC expression? Is that what we called it? Lambda calculus expression. That's what we're currently building. Now we can glance at this and say, no, y does not occur bound. Y actually occurs free. But now we want to write a function called occurs bound. We'll also have a function called occurs free, right? That goes through and looks at our three different productions for the lambda calculus language, lambda calculus grammar. We have, what do we call it, a var expression, a lambda expression, and an app expression. Those are our three productions in that grammar right now. Go ahead.
Just, I know you said in this context we're referring to expressions as bound and unbound. If you define a variable, is that considered bound?
Yes, but our language doesn't support that right now.
Okay.
Yeah, if I say int a equals 5, I just created a binding for a in Java.
Oh, in the context of scheme though, if you say define that like a and then
That would be bound in the global scope that we have in Dr. Racket. Yeah. So anytime a variable would be added to our environment, that would be a binding for that variable.
I have a question. So
Yep.
If you have the variable
We don't have lets in our language.
Oh, we don't use
Our language is extremely simple right now. Our language knows how to have a variable name. That's a var expression. We know how to do a lambda expression that only allows us to bind one variable. And we know how to do an app expression, which is a list containing 2 LC expressions. That is the complete extent of our micro language right now. We don't have a whole lot of extra. So really, bindings only occur in one place in our language right now. Make sense? All right, so we want to think about testing something here. So now we're starting to work with parse. One of the things you would have read about is parse and unparse. But that was really talking about going from a list version of a language to a symbol-based version of a language, converting between the two. I'm going to call that relatively unimportant. It just comes down to how you want your syntax to look. I'm going to keep us in a scheme-like syntax. Since we've spent some time getting used to scheme, we might as well write a language in terms of scheme, but actually have to implement the guts of it ourselves. So that'll make it at least friendly to us instead of switching gears again. So I think that, to get the language skills here, we don't need to invent some crazy kooky syntax, right? We can stick with a syntax that we're somewhat comfortable with. All right, so if this is my example input and I want to test whether a y occurs bound in here, what do I need to do? I need to, well, go ahead. Somebody give me how would the algorithm look for determining if the symbol y, does y occur? So my function call would look like this. Occurs bound, and then I would pass it this guy and y. I want to know, does this dude y occur bound in this expression? So I'm writing this function occurs bound that's going to take 2 parameters, an expression and a symbol I'm looking for in that expression to determine whether y occurs bound in that expression. How would I go about doing this?
My brain first goes to like a string parser, but I don't know if that's.
Go ahead.
Something about the vector.
Well, if we assume that we're getting an expression that does have that symbol in it, so we're not going to consider if y is even in there at all. We're assuming it's in there. What we would do is just look at the kind of inputs of the lambda
Okay.
and kind of compare.
So whenever I see inputs like this, what does that mean? What does this, what I have highlighted here, what does that
That's everything.
imply?
Bound.
That's a binding.
Mhm.
That's a new binding. That's a variable that is bound. So I can say I have found an X, and I can add that to my collection of bindings. Go ahead.
So, shouldn't we first check to make sure that it's a lambda function that you're passing in?
Well, doesn't have to be. Bindings only occur in lambda functions,
That's what I'm saying.
right?
So it'd be handy to
We could come back here and couldn't we say that y occurs free in that expression?
Okay, yeah, that's true.
That's an expression. This is just the var expression. That's an identifier. My lambda calculus expression has 3 productions. Let's go back here in the book. 3 productions. Where's lambda calculus? Is it before this? Yeah, we're pretty much, okay, here we go. Lambda calculus expression. We can have either just an identifier, like this. That's just an identifier. No bindings are taking place in there. So whatever I bump into, that guy's free. Or it can be a lambda that creates a single binding and then has a lambda calculus expression after that. Who knows how far that rabbit hole goes, right? Or we can have what's called an app expression. It's a list containing 2 lambda calculus expressions, where we already saw an example where something could occur free over here, but might occur bound over here. Make sense? That was our example for that one. So we have our micro language right here, which, we're not going to go and start writing, multi-level queues for your 350 class. You're not going to be writing that with this simple, tiny language, but it's a start. We have 3 different productions, this is a grammar. This is one production, this is another production, this is another production in our grammar. Lambda calculus expressions look like one of those 3 things, and notice that 2 of these are defined in terms of lambda calculus expressions. They're recursively defined. All right, so I'm going to need something that's going to look at the kind of expression that I care about. So if I'm calling occurs free or occurs bound on this guy, I'm going to look at it and say, what are you? Are you just a symbol? If I'm looking at just the symbol, I have no other choice but to say that symbol occurs free. Right? Only choice. Only choice I have is that symbol occurs free. That's the only context I have. Now, I might be a very small piece of a much more complex lambda calculus expression. I don't know. But all I can do is make the decision right there at that moment, where if I'm coming through here and I'm define, we writing occurs free or bound? What should I say? Bound? I think I said occurs bound. Okay, and this guy will be a lambda, and this guy takes an expression and a symbol. So I'm trying to determine if S occurs bound in this expression. Okay, so now I can do my cond, and we have 3 productions. Okay, I think I said last time that the book introduces a data type thing that uses cases, I think. But all of you obviously did the reading in a huge depth. So, you probably don't even know what I'm talking about, right? How many of you know what I'm talking about when I say cases?
Sounds familiar.
Basically what you read, just I'll fill you in on it, is they said here is 3 different ways that we can represent our languages, our data types, right? So they introduced a way of defining your own data type. I'm going to stick to what we've been doing up to this point so we don't confuse the situation. Plus, it's fun to use cars and cutters rather than extract individual pieces. We can make our own constructors. It's not the big deal. But effectively, they've introduced something called cases, which is kind of like a cond for their data type. But we're going to use a cond because we're not using the data type thing that the book introduces. We're using straight scheme to accomplish this. Okay? So we're going to ask a question. So in our cond, we're going to have room for our 3 productions. We're going to ask, am I looking at a symbol? If the expression I'm currently looking at is a symbol, I don't know which time occurs bound got call here. All I know is that I was passed an expression. One of my 3 productions. Okay? If I was passed an expression, if that expression happens to be a symbol, and you're asking me the question, does that symbol occur bound? The answer, is it false like that, or is it false like that?
I guess either way.
All right, let's just roll with it. Okay, so we'll fix it if it screams. False-ish. it's a false-ish statement, okay? As far as I can tell, when I look at this expression, this symbol occurs free, regardless of whether the expression matches it. Right? Right. Now, let's think about that, though. It's a symbol. It's not being bound here. But the question that this function is asking, though, is whether or not something occurs bound. So would my answer be different if the expression matched S versus didn't match S? Not in this context. It doesn't matter whether I'm looking at a Y or not looking at a Y. As far as EXP goes here, it doesn't occur. Does that make sense? Let me go here. Let me give you this a lambda XX. Actually, I've been using the example Y in my thing. So let's look at this one. This is a lambda calculus expression, right?
Mm-hmm.
I'm looking at, that's also a lambda calculus expression, right? So I've created a binding for Y here. But then I'm interested in whether or not something occurs in there. So it does actually make a difference. Just because my var expression, my symbol, my identifier, just because that guy doesn't create a binding, doesn't mean that I'm not the lambda calculus expression portion of something that did create a binding. Does that make sense? So we're going to need two pieces to this. On one hand, we care about whether something occurs free. We're answering two different questions here. If I run into something like this, I have a binding, correct? And at that point, I can answer my occurs free or occurs bound question based on whether something occurs in the rest of this. Just occurs. Not occurs free or occurs bound, whether it occurs. If I have a bounding for Y, then I can answer occurs free or occurs bound based on whether or not Y occurs anywhere in that lambda calculus expression. So as far as occurs bound goes, as far as this specific question we're asking, if I'm looking at a symbol, it will always be false. There is no binding here. There is not an existence for me to say that something occurs bound. All right, but we're going to write an occurs here in a few minutes that we'll be able to use for both of these because we're going to care whether something actually occurs. You know, we could have 50 bindings and then never actually have one of those bindings used. They're untapped resources. So that's my first production. My second production is something that, what is it, EQV?
Just EQ?
Will EQ work for Lambda? It doesn't matter, it'll scream at us. Car of EXP Lambda. So if I'm looking at a Lambda expression, I now have a binding, correct? Now, as far as occurs bound goes, I only care about this binding if it happens to match the symbol I'm looking for. Right? So only if the binding here matches the symbol I have found will I care whether something occurs bound someplace else. Otherwise, I don't have a binding. Okay? So I'm going to go ahead and let's create a, well, we like to practice with lets, right? So I'll get our variable name. So let var name equal, and this is going to be the CADR will give me the list. The CAADR of expression will give me the single variable that lives inside of that parameter. So if yeah. So if this is what the guy is, the cdr will give me this. The car of that cooter will give me that. The car of that will give me that. The car of the cooter. Make sense? So I'm extracting that variable name because that's a binding, right? In fact, if you even want to, we can call this guy the bound var name. That's what I just extracted. I have a binding for that guy. So now I care whether or not the variable I'm looking for, the symbol I'm looking for, S, is equal to this bound var name. If it is, then I can ask a question about my second part. So I can say, if EQ bound var name and S, if they're equal to each other, at the very least, I have a binding that matches the variable I'm looking for. But I cannot answer true yet, because I have no idea whether it actually occurs in the body. So let's get the body portion of this. The body of my lambda calculus expression is going to be this piece, whatever that is. So that is the car of the cooter. So we take the cooter, we get that list. We take the cooter of that, we get this list. The car of that gives me this lambda calculus expression, whatever it is. Might be simple, might be complex. So the body will be the car of the cooter of my expression. All right, that makes sense? So I'm extracting two pieces of information. The bound variable name and the body. If the bound variable name matches the symbol I'm looking for, now I care whether or not the variable I'm looking for occurs in the body. Make sense? Not occurs free or occurs bound, if it even occurs. All right, we're going to have something pretty similar here. This is going to be a cond. We're going to have a symbol, exp. If that's true, then we'll return equal exps. So if I found an occurrence of S in there, then I'm going to say, yes, it occurs. Otherwise, no, it didn't occur. I bumped into a symbol, wasn't there. Make sense? Next, if it wasn't a symbol, it must be a lambda. And this is a EQ car exp lambda. If I'm looking at a lambda expression, go ahead.
That's supposed to be bar.
Yeah, it's supposed to be car. Say if the car of my expression starts with a lambda, now what I care about is I care about the body of that guy. And we'll keep using lets, that way it gives us a nice variable names. I do not care about the binding here, because I'm not looking for new bindings. I am specifically on the lookout for this dude occurring somewhere inside of this expression. And a binding is not an occurrence. A binding is a more local definition of a variable. Okay, so that would not count as occurring. So I don't need to look at the bound variable here. I only need to look at the body to see if it occurs in there. So if I'm looking at a lambda, then I'll do a let, and I'll say body is equal to the CADDR of my expression. So that gets me my body. And what will I do? I'll call occurs on the body and the symbol I'm searching for. I'm on the hunt. I don't care what was just bound. The question I'm answering here is whether or not S occurs somewhere inside of this expression. Make sense? And I ultimately make that decision in that production right there. If I found a match, if I finally find you using that variable somewhere, I finally can say, yes, I found it. Otherwise, if I'm looking at a lambda, I can't make that determination yet. All I can do is blow past the binding and then say, okay, I'm going to look at the body, and then I'll just ask, does S occur in that body? And let him do his job. Else, I must be looking at a app expression, our third production. And what's an app expression? An app expression is a list containing two expressions. So what do? I want to know if it occurs in either of those expressions. So I will return or occur. Well, here I'm gonna use the thing that the book probably uses. They use like Rader and Rand for operator and operand for our app expression. All right, so I'll create a let, and we'll say the operator is the car of EXP. The Rand is the catter of EXP. All right, it's a to list. The first element would be the operator that I would be applying, if we're thinking about our language, would be the operator that I would be applying to the second element of that list, the second expression. All right, so this gets me the first element of my to list. This gets me my second element of the to list. We're calling it the Rader and the Rand. Okay, let's call it operator. Operator. Nailed it. Operand. All right, so we'll be a little bit more explicit than the book is, just to explain that in case you're comparing it to the book. All right, we have operator and operand. What will I do here? I'm going to go and say, or occurs operator S, or occurs operand S. So if I'm looking at an app expression, that means that I'm going to extract my operator, my operand. I only have one operand for this guy. That's a limitation of our current language, right? We can only have one binding, and we can only call functions with, well, we can't even call functions yet, but we're preparing to call functions that take exactly one input. Okay? We can define functions that take exactly one input. We can call functions that take exactly one input. At least those two are compatible with each other. All right, so that's what I do for occurs. So I don't care which side it occurs in. If I'm in the hunt to see if S occurs somewhere, I'm looking to see if it occurs in this guy or he occurs in this guy. If he occurs in both, great. Okay, but or returns true if it occurs in even one side of it. Okay, so that is occurs. So now with occurs bound, I can say if I'm looking at a bound var that matches my S, I can go ahead and return occurs. Since I'm doing occurs bound here, I can return the result of occurs on the body and S. But if it's not bound, then I want to call occurs bound on the body and S. Keep searching. I didn't have a matching binding here. So since I didn't have a matching binding, I don't need to find out if it occurs someplace else. I'm just going to keep going to find out if I do find a matching binding. Make sense? All right. So that's what I do in the situation of a lambda. My else means that I'm looking at an app expression. And what do? I'll return or, well, let me do my let real quick. let operator is the car of expression, and operand is the catter of expression, and I'm going to return or occurs bound on the operator and s. Oops, sorry. And occurs bound on the operand and s. That makes sense? All right, we haven't tested it, but let's just assume it works, so debug it since we're out of time. So,
You missed a car and operating occurs.
Mr. Carr,
Yeah, because you just grab the list with the lambda's input. You don't.
Where?
grab the
Where?
Input itself. In the second part of the comment.
this guy here.
Yeah.
So I get the body, which is the car of the critter. That's my body.
Isn't that just a list though?
No. Car of the critter.
Because it'll.
If I take the critter of this guy, this is the critter. This is the next critter. And then the car of that is that body, the lambda calculus expression. Yeah, so I think it's right. All right, so for your homework, I want you to write test occurs bound. Make sure you understand how this guy works the way I've written it. And then write occurs free in the style that I wrote occurs bound. Make sense? I'll give you this code as a starting point. And don't forget, we have Tech Talk tonight. Acuity's going to be here. They're one of our big employers.
Do they ever employ international students?
I don't know if they've ever employed an international student, but they definitely don't sponsor worker visas. I've had that discussion with them several times.